So, as we all know that the theme of today's topic is building an end-to-end solution for Big Mart sales prediction. So, in this session, we will be looking at the various aspects which are there in a machine learning pipeline from starting data collection to model deployment. And we will also go through the code so that we can have an idea about the coding elements as well. So to take you through the agenda that we would be covering in this session is data preparation, then EDA, then feature engineering, then model selection, then hyperparameter tuning, and model deployment. So let us start with the introduction. Basically, in this session, we will be using a data set that is available on Analytics Vidhya, and it is a Big Mart sales data collected in the year 2013. So in that data, there are about 1,500 products across 10 different cities. And the basic idea of the data set is to understand which feature of a product are important to estimate how much sales would it generate. So let me take you to the page where we can see the data. The link would be available with you at the end of the session. I will provide you the link so that you can also download the data set. As I said that this data set is available on Analytics Vidhya, so you can feel free to download the data and give your hands on it. So if we want to see the metadata or the data dictionary, then there are about 8,000 records in the data that we are going to use today in the training set, and there are about 5,000 records in the test set. So just to give a brief introduction about what is training and test set. So whenever we want to develop a machine learning model, we first want to uh, divide the whole data set into two parts, that is training and testing data sets. And whenever we develop an algorithm, we first develop the algorithm on the training set, and then we test how our algorithm works on unseen data. So basically, test data is nothing but the unseen data on which we want to test our machine learning algorithms. Moving forward to the data description. So as I said, this data is from Big Mart, and this is a sales data. And so there are the data is basically has information about product and the outlet as in the store size. So within the product, we have the product identifier, which is the unique ID of the product. We have the weight of the product. We have the fat content of that product. We have the item visibility. Then we have the type of the item. So this is just a brief description about the items, but as we go on to analyze the data, we would see what is actually within these particular columns. So in the starting, we have few columns that are related to item, and then we have another 6 columns that are related to the outlet. So which are outlet ID, in which year the outlet was
Excuse
established.
me, Bharat.
Yeah. So basically, I was referring to this data set which is available on Analytics Vidhya, and I was just going through the data dictionary or the metadata. Um, just to quickly recap what I was saying, the data is divided into two parts. In the first few columns, we have the information about what kind of product it is. Then in the few columns, we have the information about outlet, where when the outlet was established, what is the size of outlet, at which location is it located, situated, the what is the type, whether it is a grocery store or it is a supermarket. And at the end, what we want to do is we want to predict this particular column, that is item outlet sales. So for a particular item at a particular store, we want to predict what would be the sales of that product in that store. So this is the brief introduction about the problem statement that we would try to solve in this session. Let me go back to introduction. So as we started with the agenda, since we have covered what is the problem statement, let us move to data preparation. So there are, in the data preparation, basically, there are a few steps, including collecting the data. Usually the data is collected from various sources, but since we are trying to solve the problem that for which we have the data source already available. So that part is done for us. After that, we need to read the data, and we are supposed to do few different steps. So I will not go through the text, but let us directly go to the code part so that we can understand all these elements practically. Yeah, I hope the Kaggle screen is visible to all of you. All right. Thank you for the confirmation. And so what I have done is that I've downloaded the training and test data set from the Analytics Vidhya site, and I've uploaded them to Kaggle so that we could build the model over here. So just to give a brief idea about what Kaggle is. So Kaggle is a open source platform where we can get the compute, and we can create our own notebooks, and we can collaborate also with other users. So this is just if someone is not having a correct compute or the resource with them, then they can use Kaggle as a platform, and they can solve their machine learning problem over here. So in this session, we would be using Kaggle. Yes, the dataset would be provided. I will just paste the link. Let me just paste it. So let us start with the first step, the data preparation step. So the first step is always to collect the data, and as I said that we already have the data set. The next part is reading the data sets. So in the session, we would be using pandas library to read the data set. So I've imported pandas as PD. So here I am first reading the training data set. Then whenever we want to first analyze the data, we first want to see what kind of columns do we have, and using df.head, what we can do is we can actually view the first 5 records of the data set. So I'm doing the same over here. So these are the same columns that we have seen on Analytics with the site when we were seeing that data dictionary, and this is the this is the view of the first 5 records from the data set. So after that, we want to analyze what is the dimension of the data how big actually the data set is, so that we can prepare ourselves well in terms of compute and other things. So the data set here is a small data set. It is only having about 8,000 records and 12 columns. Then uh, the next step into data preparation is inspecting what kind of schema does the data has. When we speak of schema, we want to say that what kind of data type does each column has. So uh, for every column that we saw in the data dictionary, we can get the data type against it. So here object refers that this is a string type of column. So and float refers that it is a numerical column. Even int refers that it is a numerical column. So what we can do is, uh, suppose we want to check this column item fat content, and we want to just see why it is having data type as object. So we can go above and see here that under item fat content, all the elements that are present are available as string. So that is about the schema. After that, in the data preparation step, we first want to see if there are any duplicate records or not, because we don't want that there should be any redundant records in our data sets, because redundant records usually implies that it is a data error. So first, we want to check whether there are any duplicate records or not. So here in the current data set, when we check if there are any duplicate records or not, then we get a count as 0. That means there are no duplicate records. So the next step that we want to do under data preparation is that we want to check how many null values are there under each of the columns, because while preparing a machine learning model, we don't want any null values in the data set. So here, when we would inspect the Big Mart sales data, we would see that there are two columns where there are null values. One is item weight and second is outlet size. So this could be due to many reasons, but the ideal step is to impute or somehow fill these null values. So we can see that the different count of null values in the two columns, item weight and outlet size. After that, what we want to do is we basically want to replace the null values with some of the statistical value, or a value that can have a statistical reason behind it. So usually what we can do is that we can replace whenever there is a, let me write it over here, whenever you have a numerical column, what you can do is you can impute the null values with using the mean of that particular column. So that is what I'm doing over here. What we are doing is we are filling the null values using the mean of that same column. And similarly for, so basically mean is nothing but the average of that column. And for categorical column, what we can do is we can impute this with the mode. So these are basically the naive methods to impute the null values, but there are different methods uh, as we as they exist. So there is a message. If we have an outlier, then this mean value will be impacted because of the mean value. That is correct. So what we usually want to do is we want to first investigate the whole data, and after that only this step is usually done in the feature engineering part. So if you will remember from these steps that feature engineering part is done after we have done the proper EDA. So once we have done that, then what we won't face this outlier problem. So moving forward, there we here I have written few more. What I would do is I would give you the link of the notebook also so that you can go through it. So after the session ends. So here I have written few more rules how you can impute the missing values. So always remember that there is no hard and fast rule of imputing the missing values. It always depends upon the type of problem that you are trying to solve. So um, you can go through the different rules when you will go through the notebook. So now that we have imputed the null values, we are again checking if there are any other null values. So we can see that now, since we have imputed them using median, using mean and mode, so now we do not have any null values in the data. After that, we are moving to the EDA part. And so before moving to EDA, what we want to do is we first want to see the count of distinct values under the categorical columns. Categorical columns are nothing, the columns that have values as a string in them. So here I'm just iterating over the column whose data type is equals to object, and I'm seeing what is the unique count of values within them. So we can see that item identifier, under item identifier, we are having about 1500 unique values. This means that in our data, there are about 15,000 items for which we want to prepare the model, and then we want to predict the same. Under item fat content, we are seeing there are 5 different kind of values. There are 3 types of outlet, there are 3 types of location, then 4 types of outlet type. So what we will do is we would now check each of the columns so that we can have a better idea about them. So before that, I would like to share a few points about EDA. Basically, EDA stands for exploratory data analysis, and it is done to understand the relationship between the various features that are there in the column, and we want to understand the patterns and trends of the features. So whenever I say feature, it means the column. So under EDA, we have different steps. Like we first want to do a univariate analysis. So whenever under univariate analysis, we want to check the pattern of a single column at a time. And this could be done using histogram, box plot, density plot. So this would give an idea about how the spread of that particular column looks like. Then using bivariate analysis, we want to visualize two columns at the same time. Okay, the definition is wrong over here. Let me just erase it. And then what I will do is I will share the PPT with you guys also, so that you can use for future reference. So here, what, please can we get the, yeah, sure. You will get the presentation as well as the Kaggle source. So in bivariate analysis, what we do is we want to see how the relationship exists between different kind of columns. Then in multivariate analysis, we want to test out relationship between more than two columns. This could be done using scatter plot, correlation plot, and plotting three features at a time using 3D plots. And lastly, what we can do is we can, if our data is time series data, then what we can do is we can see how the data or a feature changes with respect to time. So the list does not end here, but these are the steps that you can start with when you are starting your journey or under EDA. So let us again go back to the code part. What you guys can do is, if you have any question, you can write it down on chat. I will try to answer it as I read them. Then here we are starting with the univariate analysis. At first, I'm visualizing this particular column, that is item fat content. So we can see over here that under this column we have low fat, then regular, then we again have low fat, then we have LF, then we have REG. So using the EDA, what we understand, what we get to understand about data is we can understand if there are any tweaks that are necessary in the data. For example, here low fat and this low fat in small case and this LF, all three denotes the same thing, even though since their ASCII character values are different. So we are seeing them into different bar graph. So what we can do is we can, when we will go to the feature engineering part, we can replace these values with a common string so that our model won't be confused. Similarly, for regular and REG, we can create a common string for these two so that there won't be any confusion. After that, we are visualizing this item type column. So here we can see we have different type of items ranging from dairy, then frozen foods, canned breads, then seafoods. But one thing we can note is none of the item is repeated or having a data issue as seen in the item fat column. So this is why we want to do univariate analysis of each column so that we can understand if there is any issue, and also we can understand the spread of the data. Then we have this outlier identifier, outlet identifier, sorry. So in outlet identifier, as we have seen in metadata, it is nothing but the store ID. Then we have the outlet size. So we can see we are having three different kind of stores in our data, whose size is high, whose size is medium, and whose size is small. Again, for location type, we can see that there are three different type of cities in which the stores exist. That is tier 1, tier 2, and tier 3. Then in outlet type, we can see that there are three types of supermarket type 1, type 2, and type 3. And the last one is the grocery store. So by now we have covered all the categorical columns. Now what will do is, okay, one more column was left was, okay, uh, now till now we have covered the univariate analysis of categorical column. Now we are seeing if this relationship between two columns at a time. So now we are moving to bivariate analysis. Here we are checking the outlet establishment year and outlet identifier at the same time. So we can see that for all the years, these years are arranged in ascending order. And we can see that for every year, we have a unique ID for a store. But in the year 1985, we see that we have two different kind of outlet identifier. If it would have been the case that for every year, there was only one outlet identifier, then we could have dropped one of the columns, because these two columns would then have represented redundant information. But for now, we can keep both the columns. After that, so basically why we do bivariate analysis is just to understand the relationship between two different kind of data before moving to and actually building the machine learning model and to use it as a black box. Before that, we want to understand how the data. Before moving to the model building part, we always do this EDA first. So here we are seeing outlet location type in the x-axis, and in the y-axis we have outlet type. So we can see that for tier 3 location, we have all the 4 types of stores, but under tier 2 location, we only have this supermarket type 1. And similarly, we can have an idea about tier 1 city also, that tier 1 city has supermarket type 1 and grocery store only. So you guys can go through the different bivariate analysis using the link that I've shared for the notebook. I will now go to the numerical columns, wherein we can see the statistical summary of the numerical column. So what we can do for a pandas data frame, we can use df.describe to see the distribution of a particular numerical column. So here we can see the mean, standard deviation, minimum, max. So this can also give us an idea about the range of the data, or we can say the spread of the data. So after that, yeah, I did share the notebook link. I will again share it. After that, what we want to do is we want to check the distribution of these columns. So let me go to the PPT again. So usually what we want is that the data should be present with a normal distribution. Why we want a data should be present in a normal distribution is because many of the algorithms such as linear regression assumes that the data is present in normal distribution. And also the second reason is that whenever the data is normally distributed, it help to avoid any biasness in the model. So just because of this, whenever we are analyzing numerical column, we want to see if the data is normally distributed or not. So just to check whether the data is normally distributed or not, what we can do is we can use a concept of skewness. So here in the normal distribution, you can see the mean, median, and mode, all three are equal. But whenever the data is either positively skewed or negatively skewed, then the mean, median, and mode are not equal. So let us go to the code part again, and you would get a link to in the notebook itself. Let me go to the notebook. So in the notebook itself, I have attached analytics with the link to the to understand skewness in a better way. So you can go to the notebook and click on this link so that you can understand actually what the skewness is. Yes, I will share the PPT also. So in order to identify what the skewness of different column is, what we can do is we can write a df.skew, and whenever the skewness is close to 0 or it is 0, we say that the data is symmetric. Symmetric as in the data is having a normal distribution. Whenever it is on the left hand side of the real number line, then we say that the data is negatively skewed. Similarly, when it is on the right hand side from 0 on number line, we say that the data is positively skewed. So here we can see that one of our column, that is item visibility, and this is our y variable. So is the audio not available? Let me know if I'm not audible so that I can fix the issue. All right, thank you for the confirmation. So here we can see that one of our column, that is item visibility, is having positively skewed nature. And this column, which is item outlet sales, so this is our y variable, so we won't touch it for our basic analysis, and we would left it untouched, and we will only treat our independent variable, that is item. We need to transform this particular column, item visibility. So what we can do is, here we have seen the skewness. In order to plot the different columns, we can use histogram histplot from Seaborn library to see the skewness of different columns. So here under item weight, we can clearly see that it is almost a normal distribution. Also the skewness is close to 0. Then this item visibility, we can clearly see that the skewness is positively skewed. Then moving to item MRP, we can see that it is against, yeah. So here, so KD is just a feature to represent, to enable the density. So here the plot is made with respect to the density of the values. So here under MRP, we can clearly see with our eyes also that it is almost normal distributed, and even the skewness is the same. For this analysis, we would keep it as it is. So we would treat these variables in the feature engineering part, but in the EDA, we are just identifying if there is any other data issues. Then in order to see the the value counts of this particular column, that is outlet establishment year. So here we can see that most of our data is from 1985, and then almost every year we had about 900 records for every year, except the year 1998, where we only had the minimum number of record, that is 555. It is good to see that you guys are helping each other to answer the query, so that we can cover the session in time. So here I have also attached one more link, which is the link to the outlier detection and removal. So this is also a analytics with their link. You guys can go through this and understand the various methods of outlier detection. So we are doing this outlier detection in under EDI itself. So what I have done, okay, let me go to the slides. So before moving to outlier, first let us understand what is IQR range. So if we would arrange our data in the ascending order and we would divide in 4 equal parts, then the first part would represent the quartile 1, the second part would represent quartile 2, and similarly the remaining of the quartiles. So quartile is nothing but under quartile 1, all the data that is below the 25th percentile mark would exist in quartile 1. In easy terms, median represent quartile 2, because median is basic nothing but if we arrange the data in ascending or descending format, and the central value is known as median. So here also the central value, that is the 50th percentile quartile, is known as median. And at the quartile 3, we have this 75th percentile. So this is a okay. So this the difference between Q3 and Q1 is known as interquartile range. And statistically speaking, if we want to find out if there is any outlier in our data set, then there are multiple ways, but one way to identify outlier is using IQR range. So this is statistically what we say is that Q3 plus 1.5 times of IQR range would give us the maximum limit or the maximum threshold till which our data can exist. Similarly, we can also find out the minimum range. So any data point beyond these limits is considered an outlier. So there is a question, which method is generally used for outlier detection? So basically both methods are used, IQR and z-scores. It depends upon the nature of the problem, but you can try both the method and see which method works the best for you. So both the methods are used in the industry. And then there is a question, why only 1.5 only? So basically what we say is that, so as someone has written z-score, Mono has written z-score. So whenever we speak about normal distribution, we say that the 95% of the data is covered in 3 standard deviation from the center. And we can get the limits of that 3 standard deviation using the given formula, that is, we can multiply 1.5 by IQR to find out the extreme limits. So that is why we use this. This is a statistical formula. After that, let us go back to the code part. So here also what I have done is I have first find out the quartile one. Quartile one is nothing but, as we said, that when we will divide the data into 4 equal parts, the first part would represent the quartile one, and the 75th percentile would give us third quartile. IQ range is the difference between the two, and we can identify the outliers using the given, as we have just seen. If anything is below or anything is above, then we can say that it is an outlier. So Ghansham has pasted about the lower bound and upper bound. So we can see here that uh, anything beyond 2.7 standard deviation is considered outlier, because we say that whenever there is a normal distribution, almost 95% of the data is covered within 3 standard deviation. So that is why we use 1.5 over here. So in order to visualize the representation that we just saw on in the PPT, we can prepare a box plot. So there is a question 2.7, which is close to 3 is pretty, yeah, that is correct. So as I was saying that in order to get the same visualization that we were seeing in the PPT, we can use box plot to identify if there are any outlier. So we can clearly see there are no outliers beyond the extreme limits. Then we can check it on another column, which is item visibility. So we can clearly see, as this was positively skewed also, and many outliers are beyond the upper IQR limit. And we can see that the total count of outlier is 144. Similarly, we can see the outliers for other columns also. There is no outlier in under item MRP. And so we would treat this outlier in the feature engineering part. After that, we have this correlation matrix. This comes under multivariate analysis, wherein we want to see the relationship of one feature with respect to many different features at a single point. So here what we can see is that how this is our target variable, and basically we want to see how different variables are behaving with respect to the target variable. So we can see that these variables are very less correlated. Correlated as in these values, whenever outlet sales is increasing, item weight is also increasing. This would mean that it is highly correlated. So what has to be done to the outlier? Yeah, so we would come to this question more when we will move to the feature engineering part. Right now we are doing the EDA. So as I said, as I was explaining correlation, so whenever we want to say that there is a high correlation, it means that the values increase proportionally in a proportional manner. So whenever outlet sales is also increasing, if item weight has been increasing, we would have seen a higher number close to 1 over here. But it is not the case. That's why we are seeing it is very loosely correlated. Similarly for other features as well. But for item price, we can see that item price and outlet sales are very much correlated. And we can say this heuristically also, that whenever an outlet would have expensive products in it, then it might generate a higher sales also. So we can see that here also. After that, let us move to feature engineering. So since we are running short of time, I will try to cover the topics quickly. So first of all, we are creating the categorical columns if they need any treatment. So as we first in found out that under the item fact content column, there were spelling ASCII character difference between the same kind of values. That is, low fat was also written as in small case low fat. It was also written as LF. So here, what we are doing is we are just mapping uh, these back to their original form. We are mapping LF. We are mapping to low fat, and similarly, REG is being mapped to regular. And after that, we are seeing what is the count. So at the end, now we are only left with two kind of fat content, that is low fat and regular fat. Then we are moving to label encoding. So for a machine learning problem, in order to train a machine learning model, we first want to convert any kind of categorical column into numerical columns. So the general rule is that if you are seeing that there are the unique values under a column are high, then we use label encoder. And if we see that the values are very low, like under the case of item fat content, we see that there are only two unique values. So here we can apply one hot encoding. But if we see that there are many different uh, unique values under each of the column, then we apply label encoding. So here we are transforming the three categorical columns. After that, for the remaining of the columns, we would be applying one hot encoding, because as I just said, the unique values under these columns are very less. So why we are applying this under the case of why we are applying label encoding for whenever we have high number of unique values? The reason is that we don't want to apply one hot encoding for such features, because it would eventually increase the number of features. So basically here, whenever we are applying label encoding, each of these is being mapped to one unique values. So here, this would map to 1, this would map to 2, this would map to 3, this would map to 4, and so on. If we would have applied one hot encoding, then it means that we would have transformed that particular column into a set of different columns. Suppose here we are seeing outlet size. Earlier, under outlet size, there were only three distinct values, that is high, medium, and small. But after applying one hot encoding, what we have done is we have transformed this column. So whenever the column value was high, we would see a 1 over here. Whenever it was medium, we would see 1 under this particular column. So we don't want to do this for a column that is having a high number of unique values, because eventually the feature size would increase, and we don't want that, because we want to keep less number of features so that our model can be trained easily. So similarly, um, we are applying one hot encoding to the remaining of the columns. After that, now we are moving to outlier handling part. Here, as I have again plotted it. So as we saw that there are about 144 outliers, and there are different methods to deal with the outliers. Either we could cap the outliers. Capping means we would cap them to the extreme limit. either we could clip them, uh, or either we could drop them. So it all depends upon the nature of the problem that we are trying to solve. Another way to deal with outlier is that we can perform some kind of transformation, that is a log transformation, box Cox transformation. So what these transformation does is they bring the data from skewed distribution to a normal distribution, and in the normal distribution we won't see any outlier. So again, I'm saying that it depends upon the nature of the problem. So suppose if you would try to apply log transformation for this column, you would see that it won't work, uh, because machine learning, we have to try every possible solution that can be worked for our use case. And in this case, I tried log transformation, box Cox transformation, and they were not able to be applied to this particular column. So what I did was, um, I used Yo Johnson transformer. It is a similar. It is similar to box Cox transformation, um, and using this transformation, what we can do is we can bring the skewed data from, we can change the skewness to a normal distribution. So after applying the transformation, the data is turned to normal distribution. So as in the beginning, I said that we want to try to keep all the columns normal with a normal distribution, so that uh, the machine learning models can be easily trained, and also the convergence time also reduces. Convergence is that we can easily find out the best fit of the model if our model is normally skewed and if it is scaled. So these are few things that we keep in mind. So when you will see the PPT and the notebook, you will have all the points, so that whenever you try to solve any other problem, you will have uh, all the steps that are needed in a machine learning problem to solve any machine learning problem. So after that, once we have applied this transformation, we are again checking if we have any outlier or not. So we can see over here that we are left with 0 outlier after the transformation. So from this, we understood that it is not always necessary to clip the outliers, but we can apply a various transformation also. After that, we are moving to model selection part. Yes, the recording will also be uh, available. So there is a question for tree-based approach. Do we need normalized data? So no. So the answer is no. We don't need normalized data, or even we don't need scaling uh, for a tree-based approach. But in order to reduce the convergence time of the model, we tend to do these steps so that you can um, find out the best algorithm that works for you in a smaller span of time. So that's why these are some standard steps that we want to do, but it is not necessary for tree-based approach. So here what we are doing is, under model selection, um, we have picked up 3 different algorithms: XGBoost, LGBM, and linear regression. And first, what we are trying to do is we have fitted the, we are dividing our data into X and Y variable. X is the independent variable and Y is the dependent variable that we want to predict for. So everything is first going to X, all the independent variable, and the Y variable we have the dependent variable. Then we are splitting the data into two parts, that is training and test set, so that we can evaluate which algorithm works the best for us. Here I have selected test size as 0.2. That means 80% of the data randomly would go to X, and 20% of the 80% of the data would go to X trained, sorry, and 20% of the data would go to X trained. After that, we have created objects of these particular algorithms. So here we can see that these objects do not have any hyperparameter in it, because under model selection, what we want is that we want to keep and we want to test the models with default parameters. So this is being done to identify which algorithm works the best with without any parameter tuning. So here what we are doing is uh, we are applying cross validation, and we are passing the models that we have specified above, and we are testing how they are working on the solution. So also we are okay, let me, so I will have to rerun the code to get you to the output of these particular cells, but at the end of after you would run these cells, you would find out that XGBoost is the algorithm that is giving us the best results. And what we would want to do after that is we would want to hyper tune the parameters of this particular algorithm, that is XGBoost, so that we can uh, optimize the output for this algorithm. So under model selection, again to recall, under model selection, what we do is we create objects of various models, and we see how they are working on our data. Once we see the which is the best algorithm that can be applied, we choose that algorithm, and then we apply hyperparameter tuning to that particular algorithm. So here also I have selected XGBoost, and I have selected few parameters. So this list is not exhaustive. Many more things can be done over here, but I have just selected two parameters such as an estimator and learning rate. So uh, uh, information about learning rate and an estimator is beyond the scope, as also we are running out of time. So I will just go to the grid search, what we are doing in this. So uh, basically what we are doing is we are testing every combination of this parameter. Currently we have passed two parameters. So once in the first run, learning rate 0.05 would be picked up with an estimator 500. In the second run, 0.05 would be picked with 750, and we would have a result after selecting these particular combination. And at the end, using the grid search, what we can do is um, we can find out which were our best parameters. And once we know the best parameter, what we can do is we can use those parameter to predict our y variable. And similarly, using these parameters, then we can make the prediction on our final test set, which was present in the link to the problem set. As you remember, there were two set, training and test set. We first picked out the training set. We divided it into two individual subset so that we can identify which is the best algorithm for the particular data set. And once we have done that, we use the same parameters uh, to generate the output on the test set. So that is about the different steps. Let me say the PPT again. So we have seen feature engineering. Under feature engineering, we saw different steps like feature encoding, feature selection. Then under model selection, we also saw what all is done. Uh, so we saw that we need to divide the data into two parts. In the correct, we can choose the appropriate metrics. We need to select a candidate model. Then, so we selected three different kind of candidate model. Then we fit the candidate model on the training set. After that, we evaluated. Yes, you will get the slide also. After that, we evaluated the candidate model on testing set. Then we chose the best model. Then we fine tune the hyperparameters of the chosen model. And finally, we validated the model on the test set. So these are the steps. After that, we have model deployment. So there are a few steps to model deployment. What we need to first do is, once we have finalized which model is working the best, we need to save that model. So after you have saved that model as a file, then you need, there are various ways of deploying a model. One way is using Flask application. So using Flask is basically uh, uh, all the code is written in Python only, so there is no difference in that. And after that, you can load the particular model. You can accept the data as a request, um, and you can apply the same pre-processing that you did for the training data, and then you can make the prediction. And at the last step, you can return those prediction as a JSON output. So um, I know this is a very high level view and uh, about deployment, but um, right now I could not prepare a live example for you guys for giving you a live demo of Flask application. Uh, but what I have done over here is I have written a sample code of how this actually works. So basically what we do is we create a endpoint. And yeah, thank you, Neha, for answering the question. So what we do is basically we make an endpoint, and we can define the endpoint. So here the endpoint would be having a address which would end with sample endpoint, and the method would be post. We can also write a get method. What we will do is we would carry out one more session about deployment itself, so that you can understand deployment in a better way. In that, what we will do is we would start from the scratch just for model deployment, and you can understand then the ins and outs of model deployment in a production environment. Yeah, you need to pickle the model. Pickle the model is basically saving the model that you just trained, and then we use the model file as an input while reading in the Flask application. So that's it about the model deployment. I know that there are still elements remaining with respect to model deployment, but I promise that in another session we would definitely cover it. So I'm open to the questions. You guys have any other questions? Yes. What we will do is we will provide you the PPT also and the links to various elements that we talked about. In the PPT, there are all the steps that are generally taken in a machine learning project. So you can use it as a reference for your future analysis. And we will also conduct a session on Flask deployments on a production scale so that this topic can be covered thoroughly. Thank you. Thank you, everyone.